Have you ever felt totally lost in an electronics store, just staring at a wall of numbers, GB, GHz, Mbps? It's like an alphabet soup that's designed to be confusing. Well, not anymore. In this explainer, we are going to crack the code on tech specs, so you can stop guessing and start making way smarter choices. Let's get right into it. So here's our game plan for today. We'll start with why this jargon is so darn confusing in the first place. Then, we're going to tackle the three big areas: data size, processor speed, and connection speed. And finally, we'll put all your new knowledge to the test. It's a simple roadmap from confusion to total clarity. All right, first things first, let's talk about this alphabet soup of tech terms and why it's so confusing to begin with. This is the big question, isn't it? These terms, they look almost identical, but they represent completely different things. I mean, one measures size, another measures thinking speed, and the third measures transfer speed. Getting them wrong can seriously mean overpaying for something you don't even need, or, maybe worse, being disappointed with a device that's just too slow for you. Okay, so let's start with our first key area, storage. This is all about the digital space where your files, your photos, and your apps actually live. You know, everything in the digital world, I mean everything, starts right here with a humble bit. Just think of it like a tiny light switch that can either be on or off, a 1 or a 0. It is the absolute atom of all information. But, a single bit on its own can't hold much information. That's why we group 8 of them together to form a byte. And to give you a really simple example, it takes one single byte to store just one character, like the letter A or the number 5. Now this right here, this is probably the single most important conversion you need to remember. 1 byte equals 8 bits. This tiny detail is the source of so much confusion, especially when we start talking about internet speeds later on. So seriously commit this one to memory. 1 byte is 8 bits. And from there, things just scale up, and I mean fast. A kilobyte is 1,000 bytes. A megabyte is 1,000,000. A gigabyte is 1,000,000,000. And these days, we're all dealing with terabytes. That's 1,000,000,000,000 bytes. This is the language of your phone storage and your computer's hard drive. Okay, so we've covered size. Now let's talk about speed. And I don't mean internet speed, not yet. I'm talking about the thinking speed of a device's brain, its processor, or what we call the CPU. The base unit here is called a hertz, or Hz. Now, 1 hertz is incredibly slow. It means the processor is doing just one calculation every second. You can kind of think of it as the processor's heartbeat. The faster the heart beats, the more work it can get done. Of course, our modern computers are way, way faster than that. We measure them in gigahertz, that's billions of calculations every single second. So a higher GHz number generally means a snappier computer, especially if you're doing demanding stuff like gaming or video editing. So when you see GHz, just think raw processing power. Okay, we've done size and we've done thinking speed. Now it's time for the third piece of this puzzle: how fast data actually moves from one place to another. This is your internet speed, your download speed, what the pros call throughput. And here is the absolutely crucial point. Network speed is measured in bits per second, not bytes. Remember those tiny ones and zeros we talked about? We're measuring how many of those can be sent down the wire every second. This is what your internet provider is actually selling you. And that brings us to the classic question that trips almost everyone up. So take a look. One has a lowercase b, one has an uppercase b. They look almost the same, but one of these is dramatically faster than the other. What do you think? Any guesses? The answer, it's all about that 8-to-1 rule we talked about. The lowercase b in Mbps stands for megabits. That's what internet providers advertise. The uppercase B in Mbps stands for megabytes. That's often what your computer shows when you're downloading a file. And since there are 8 bits in a byte, 100 megabytes per second is 8 times faster than 100 megabits per second. So what's the lesson here? Always watch the capitalization. Okay, you've learned the fundamentals of storage, processor speed, and throughput. So now it's time to actually win the numbers game by putting all of this together. So first up, a little storage challenge. Imagine you need to delete the biggest file on your computer to make some space. Okay, so here are your files. We've got file A at 16,000 gigabytes, file B at 900,000 kilobytes, C at 1,000 megabytes, and D at 1 terabyte. Now, that 900,000 number for file B really jumps out, doesn't it? It looks huge, but as we now know, the unit is everything. We have to convert them to really compare them. And look at that. Once we convert everything to gigabytes, the answer is just so obvious. File A at 16,000 gigabytes is actually 16 terabytes. It absolutely dwarfs all the others. And that huge-looking 900,000 kilobyte file, it's not even one whole gigabyte. This just goes to show you can't trust the number alone. All right, final challenge. This time we're talking about speed. Which of these internet connections would you rather have for the fastest possible downloads? Here are our options: 100 kilobits per second, 10 megabits per second, 1 gigabit per second, and, oh, look at that, they've thrown in 100 megabytes per second just to try and test us. Let's see which one is actually the fastest. And the clear winner is C, 1 gigabit per second. A gigabit is 1,000 megabits, which just blows the other bit-based speeds completely out of the water. Even that trick answer, 100 megabytes per second, well, that only converts to 800 megabits per second. The gigabit connection is still faster. See? That's the power of understanding the prefixes. So, let's just wrap all this up with 3 golden rules you can take with you. First, always, always convert to the same unit before you compare anything. Second, never confuse storage bytes with network bits. And third, remember that a really big number with a small unit can be way smaller than a small number with a big unit. You are now officially equipped to decode the jargon. You can walk into that store, look at those spec sheets, and know exactly what you're paying for. So the only question left is, what matters most to you? Is it storage, speed, or power? The cool thing is, now you have the tools to decide for yourself.